Hello everyone! Welcome to Teacher Hanji's channel. For today's tutorial, I'll discuss about combined variation. Here are our objectives for today's tutorial. First, illustrate situations that involves combined variations. Second, write equations of combined variations. Third, find the constant of variations. And fourth, find the unknown variables. I have here some examples in which we can find combined variation. First, the force of attraction of a body varies directly as its mass and inversely as the square of the distance from the body. Second, the acceleration of an object varies directly as the force exerted and inversely as its mass. Third, the electrical resistance of a wire varies directly as its length and inversely as the square of its diameter. So here are some examples in which we can find combined variation. So what is combined variation? A combined variation is another physical relationship among variables. This is the kind of variation that involves both direct and inverse variation. So along the way, we will use equation in which we can see direct and inverse variations. The statement z varies directly as x and inversely as y means z is equal to k times x divided by y, where k is the constant of variation. Remember that the k or the constant of our variation should not be equal to 0. So as you can see in our statement, the first variable is written at the left side of our equal sign, varies directly as x, which is the same in direct variation. We just simply multiply our constant term and the variables given, and inversely as y. Therefore, y will be our denominator, same as in inverse variation. So to find the constant of variation, we use the equation k is equal to z times y over x. Okay, so let's begin. Express the following statements as equation of variation using k as constant. First, t varies directly as a and inversely as b. Since our first equation is t, then it will be written at the left side of our equal sign, followed by varies directly as a and inversely as b. Therefore, we have t is equal to k times a over b. Since in our statement it says varies directly, then we multiply the constant and the other variable, and inversely, then we make the other variable be the denominator of our equation. Therefore, the equation will be t is equal to k times a over b. So let's try another one. Y varies directly as x and inversely as the square of z. So we have here y again to the left side and varies directly as x, in which x here will be multiplied to our constant and the other one will be in our denominator. So the equation will be y is equal to k times x over z squared, since it says here that it should be the square of z. So let us have the third one. The pressure P of a gas varies directly as its temperature T and inversely as its volume B. So again, we have here the variables P, T, and V. Therefore, our equation will be P is equal to varies directly as T. So we have K times T over inversely as V. So over B. Now, this is the equation of this statement. So let us have the last one. The electrical resistance R of a wire varies directly as its length L and inversely as the square of its diameter D. So we have here the variables R, L, and the square of D. So our equation will be R is equal to K times L divided by b squared. So that is how we write the equation for the following statement in combined variation. So let us try to solve some problems involving combined variation. If r varies directly as s and inversely as the square of u, and r is equal to 2 when s is equal to 18 and u is equal to 2, find the constant of variation. So remember that we have here two ways in solving the constant of variation of a given combined variation. The first one is using its equation, while the second one is using the other equation in which you are finding the value of k. So let us start first with getting the constant of variation using the equation given in our statement. So it says here that r varies directly as s and inversely as the square of u. Therefore, the equation for this one will be r is equal to k times s, since it says here that it varies directly as s, and inversely, then we have here the denominator is square of u or u squared. So this is the equation of our statement. So now, let us substitute the values of r, s, and u in our equation. So we have here 2 for the value of r here, 18 for the value of s, and 2 for the value of u. So we have 2 is equal to k times 18 over 2 squared, which is equal to 2 is equal to 18k over 4. Now, to isolate k here, since our goal is to find the constant or the value of k, we need to multiply both sides by the reciprocal of 18 over 4. So that will be 4 over 18 to the both sides in order to make 18 over 4 times 4 over 18 be equal to 1, or we simply cancel out the two of them since that is equal to 1 already, leaving k alone to the right side. Now, let us simplify this one. Let us multiply the numerator and the whole number here. 4 times 2 is equal to 8 and over 18, which is equal to our k. Let us simplify this one by dividing both numerator and denominator by 2. Therefore, k is equal to 4 over 9. And that is the constant of our variation given this statement. So let us try the other way in solving this one. If you don't want to use the equation r is equal to k times s over u squared, let us find the constant of variation using the other equation in which we are finding the value of k already. And that equation will be k is equal to r times u squared over s. For you to easily remember on how to get the equation for constant, then we just simply multiply the variables at the left side of our equal sign and the denominator, which will be the new numerator. So we have here r u squared. And the other variable beside k will be the denominator for this equation. Now that we have this one, let us now substitute the value of r, value of s, and value of u in our equation. Let us see if we will arrive with the answer 4 over 9 as well as the same with the first activity. So we have here k is equal to 2 for the value of r and 2 again for the value of u squared over 18 for the value of s. Therefore, simplifying the numerator, we have 2 times 4 over 18, and 2 times 4 is equal to 8 over 18. And 8 over 18 can be in its simplest form by dividing both numerator and denominator by 2. Therefore, k is equal to 4 over 9. And that is the constant of this statement, which is the same with the other one. So you may use the equation alone, or you may use the equation for getting the constant or value of k. So let us try another one. P varies directly as q and square of r and inversely as s. Find k if p is equal to 40 when q is equal to 5, r is equal to 4, and s is equal to 6. So again, we are asked to find the value of k or the constant of variation. So let us start getting the value of k using the equation of the given statement. It says p varies directly as q and s and the square of r. So that will be the direct variation. And inversely as s. So this one will be our denominator. So our equation will be P is equal to K times Q times R squared over S. Now, let us substitute the value of P, which is 40, value of Q, which is 5, value of R, which is 4, and value of S, which is 6. So we have here 40 is equal to K times 5 times 4 squared over 6. And 4 squared is equal to 16. So we have 40 is equal to K times 5 times 16 over 6. And 5 times 16 is equal to 80. Therefore, we have here 40 is equal to 80K over 6. Now, let us isolate K here by multiplying both sides by the reciprocal of 80 over 6, which is 6 over 80. That way, this one will be equal to 1, leaving K alone to the right side. Let us now simplify the left side, multiply the numerator and the whole number. So we have 6 times 40 is equal to 240 over 80. And 240 divided by 80 is equal to 3. Therefore, our K should be equal to 3, or the constant of variation is equal to 3. So let us try another way in solving this problem. So we have here same problem and we have same equation, which is P is equal to K times Q times R squared over S. So our task now is to find the equation for K. So to find the equation of K, we will just simply multiply the variables at the left side of our equal sign and the denominator in our fraction. So we have P times S, and this will be our numerator. While the other variables will be the denominator. So we have K is equal to P times S over Q times R squared. So this will be our formula in getting the value of K. Let us now substitute 40, 5, 4, and 6 to our equation. So we have 40 for the value of P, 6 for the value of S, 5 for the value of Q, and 4 for the value of R. Then we have K is equal to 40 times 6 over 5 times 4 squared. Simplifying that one, we have 240 over 5 times 16. And 5 times 16 is equal to 80. Therefore, we have K is equal to 240 over 80. And 240 divided by 80 is equal to 3, and that is the constant of our variation or the value of our K. So again, you have here two choices in finding the constant of variation. It's either you use the equation or you use the equation for the constant. So for our next two activities, we will use the equation for our constant. So let's try solving the next statement. If x varies directly as the square of y and inversely as z, and x is equal to 12 when y is equal to 3 and z is equal to 6, find x when y is equal to 9 and z is equal to 6. So our task now is to find the value of x when y is equal to 9 and z is equal to 6. So the same with what we done in direct, inverse, and joint variation, we must identify first the constant of variation given the first facts, in which x is equal to 12, y is equal to 3, and z is equal to 6. So let us formulate first an equation given this statement. X varies directly as the square of y and inversely as c. So our first variable is x, therefore that will be written at the left side of our equal sign, which is equal to k times, we have here square of y, so we have y squared here, over, since we have here inversely as z, so the denominator will be z. So the equation is x is equal to k times y squared over z. Now, our task is to find the constant first, just to identify the value of x when y and z change their values. So to find the value of k, we simply multiply this one, x times 7, and make the other variables as the denominators. We have k is equal to x times z over y squared. Now, from our first given, it says x is equal to 12. Let us substitute it here. Z is equal to 6, then substitute it here. And y is equal to 3, then substitute it also. So we have k is equal to 12 times 6 over 3 squared. And simplifying the numerator and denominator, we have 72 over 9. And 72 divided by 9 is equal to positive 8. And that is the value of our constant. Now that you know the constant of these equations, then let us move on with the other one. Let us find now the value of x using the original equation. X is equal to k times y squared over z. But this time, we will substitute the value of k that we obtained here and the new value of y, and as well as the value of z. So we have x is equal to 8 times 9 squared over 6. And 9 squared is equal to 81. Then multiply it by 8 and divide it by 6. And 8 times 81 is equal to 648. Divided by 6, therefore x is equal to 108. And that is the value of our x. So let us have our last example. W varies directly as x and y, and inversely as square of v. And W is equal to 1,200 when x is equal to 4, y is equal to 9, and v is equal to 6. Find W when x is equal to 3, y is equal to 12, and v is equal to 10. So again, we will find the constant of the variation. Then after we get the constant of variation, we will now find the value of W when x is equal to 3, y is equal to 12, and v is equal to 10. So let's start first with our statement. W varies directly as x and y, and inversely as square of v. Therefore, the equation will be W is equal to k times x and y over square of v. So we have v squared. Now, let us find the constant by multiplying w and v squared and make x and y here as the denominator of our fraction. So we have k is equal to w v squared over x times y. Now, let us substitute the value of w, which is 1,200, and value of v, which is 6. Then, at the denominator, let us replace x by 4 and y by 9. So we have k is equal to 1,200 times 6 squared over 4 times 9. So let us simplify this one. The answer will be k is equal to 1,200 times 36 over 36. So if you notice, we have here a factors of 36 in our numerator and 36 to our denominator. So we can cancel that out since it is equal to 1. Therefore, our k is equal to 1,200. Now, let us find the value of w given the equation w is equal to k times x times y over v squared. So we know that our k is equal to 1,200. Let us replace it by that number. Let us replace x by 3, y by 12, and v by 10. Therefore, we have equation w is equal to 1,200 times 3 times 12 over 10 squared. And 1,200 times 3 times 12 is equal to 43,200 over 100 for 10 squared. And 43,200 divided by 100 is equal to 432. And that is the value of our W. So that is how we find the constant of variation equation of variation, and the known variables in combined variations. Thank you for watching. See you again in my next video. Bye!